Hey guys, so I wanted to show you this A20M multicolor printer by GEEETECH. There's not a lot of people talking about this, and I thought that was kind of weird. So I wanted to do a review of it and take it through a print so that you guys can see how it works. Right here, it started a short print of the infamous calibration cube, the 20mm cube, and we'll have a look at that once it's done. GEEETECH has made a bunch of printers, and I believe this is their first multicolor printer, which is what the M stands for in the A20M designation. So here's a shot of the printing in action, and there you can see the bed looks kind of shiny, but it's not actually that shiny. I think that's just the backlight making it look that way. But what I did want to talk about is the build surface of the bed. And it is a heated bed, which is a huge bonus if you're looking to print in ABS or other materials like TPU or PETG. You definitely want a heated bed for that. And it helps with PLA as well. I got the bed heated here to 55 degrees Celsius, and it's printing the calibration cube. The build platform material is really good on this printer. I've used a bunch of bed materials in the past, and honestly, I like this material the best. PLA adheres really well to it, and I've never had an issue of a part coming off mid-print. After, everything has been dialed in, getting that first layer dialed in just right. It's been great. And as you can see there, there's my cat. Excuse the cat. The extruder assembly has a spot for a bed leveling sensor, and that comes attached out of the box. Out of the box, putting the printer together, there's a real easy assembly procedure. It's a few screws, a few cables to plug in, and you're off and running. Of course, after doing that, you have to level the bed, which is standard, 3D printing procedure. If you've had or owned a 3D printer in the past, you know what that's all about. You start off at one corner and go through the menu, select the next corner, adjust the knob there that we see in the bottom right-ish underneath the build platform. That's what levels off that corner, and then you continue around in a counterclockwise direction until all the corners are level, and you use an A4 sheet of paper for that. And that worked relatively painlessly, I have to say. The bed didn't seem to have any, weird leveling issues, like it was warped or anything. And we'll see how it holds up over time. I did some tweaks, however, on the steps per millimeter to get the dimensional accuracy dialed in, as well as the steps per millimeter on the extruder itself. I can give you more info about that if you guys need. Just let me know. So once you get that dialed in, I think the cube will come out with a resolution or an accuracy within 0.1 millimeters on that 20 millimeter cube. And that is really great. I'm completely happy with that. And I think it would be really difficult to get any better than that on a printer of this type. So as I mentioned, this print here is not a multicolor print. This is just a straight up one color print. And even though I have two colors loaded, you can't really tell by the video, but both colors are loaded up. And they recommend that, the company recommends that both filaments be loaded up, and that is to prevent the filament from back winding up the empty side of the hot end. So that's what's going on here. So I think what I'll do now is I'll show you a completed multicolor print, one that I completed previously. It is the stock blended 3D printed object. It's a stock print, came included on the SD card. I have orange filament printed, installed on one side, and blue filament on the other. It's Boots filament, which is now out of business, and is maybe not the best choice of colors to blend, but you can see pretty clearly that it starts off with pure orange and transitions to blue, and the blue-orange combination in the middle there. If you know anything about color mixing, you know that blue and orange gives brown. And that's pretty much what we got, a little bit of brownish color and all the way up to blue on the top. And it looks pretty good, I think. Pretty good. I'm not sure about the specifics, such as the layer height on this model, because it's just simply G-code that came stock. And that's typically the file format that this printer and printers of this type accept, G-code. Rather than, say, STL or OBJs. And on the print card, there's actually, on the SD card, there is another stock print, which is the bicolor lizard print. And I'm going to print that one out later on as well, show you guys what that looks like. For that one, it will require a purge block in order to get a clear, clean delineation between two different printing colors. The dog that I have printed earlier is not that, right? It's a blended color, and it blends continuously from one color to the next. I think I'm going to have to try some different colors and see what that looks like. So this multicolor print was not without some trial and error. There were some issues with the printer, but GEEETECH has been really responsive. Their tech support has been awesome. Thank you, Serena. She's helped me out with an issue I have with the card reader device on the front panel. There were two problems that kind of threw me for a loop for a while. When I was trying to diagnose what was going on, it was proving to be difficult because two things were happening. One was that the card reader attached to the main LCD display would not reread the card if you took it out while it was powered up. And I have two A20Ms, and the second printer does not exhibit this behavior. So you could take the card out, and you could load a G-code on it, reinsert it into the printer, and it will reread the card, and off you go. This printer, this A20M, for some reason, that would not happen. You would have to reboot the printer before it recognizes the card. So if you remove it and reinsert it without rebooting, it just simply says no card inserted, and that's it. The other weird problem with this one was that if you press the selection knob on the front panel, it would often just disconnect the SD card as if you had removed it. And it would report that it couldn't access the SD card until you rebooted. So I'm hoping that will go away with the replacement panel that GEEETECH is sending, and I'll let you guys know what happens with that. I did receive it, by the way, so I just have to install it. This, by the way, does not play a role when you're connected by USB to the printer. If you're using a slicer to print to the printer directly. Then you essentially bypass the SD card completely, and it's not an issue. So that's great. I've been printing a lot that way, actually. The other issue, and this is one that threw me for a loop, as I've seen a few other people having this issue as well, it appears, and that one extruder seems to get jammed frequently. I would hear the extruder clicking and see that no filament was coming out. So the clicking sound and no filament being extruded is a classic symptom of a clogged hot end. So off you go. You take apart the hot end, clear the obstruction, put it back together, start printing again, and a very short time later, same thing would happen. So this happened multiple times, and I'm just thinking, like, this is crazy. It's a brand new printer. Just can't be clogging up that easily like this. It doesn't make any sense. So with the gear slipping on the filament, I had to take a real hard look at the hot end, and I realized it wasn't clogging. Something else was going on. So I took apart the extruder motor and the stepper motor assembly. I ripped it all apart, and I discovered what I believe is the issue. In there are two gears. There's a smaller gear that's keyed to the stepper motor shaft, and then you have the larger gear that engages with the filament directly. And actually both the two gears engage with the filament on either side. So they're pressing on the opposite side. So what's going on is that the little gear that is keyed to the stepper motor was put on upside down. And I say that because there's a set screw in that little gear, and from the factory it was positioned too high, and it was interfering with the contact on the filament as it was coming through. And that was the source of the whole problem, causing a little bit of a hang up there on each rotation. There's a small detent where it was losing the ability to grab tightly onto the filament. And so, one option would be to grind down that set screw a little bit. But a simpler solution would just be to remove that smaller gear, flip it around 180 degrees, and put it back onto the shaft of the stepper motor, so that the set screw is actually closer to the bottom of the shaft rather than to the top of the shaft. So you put that back together, tighten it up, put it all together, and there you go. No more issues. So the A20M, as you can see, is printing like a dream now. So guys, that's a huge one. If you have that issue, give that a shot. I wish I had taken some pics while I was doing that little tweak, but it's really not difficult to do. If you go slow, you're going to be fine. I think that's going to work for you. The other thing to be aware of, too, is that when you reassemble that assembly, don't over-tighten those screws. There are 4 screws that hold it together. You don't want to over-tighten them, and that's really critical. So you want to tighten them just enough to keep the thing from flying apart. So not too tight, otherwise it binds up on the gears and it keeps them from turning, and you end up with a similar situation. So nice and easy on those 4 screws. All right, and that will fix that problem. At least it worked for me. So I was scratching my head for the longest time over that one, and it was actually much easier of a fix than I thought it would be. So the calibration cube is almost done. It's nearing completion. And as you can see there, I have the part cooling set quite low. I'm in Canada here, and it's still quite cool here. So I actually don't generally use part cooling. I'm printing with PLA, printing at about 200 degrees Celsius with a 55 or 60 degree Celsius bed temp. And I honestly don't use cooling at all, but I just wanted to experiment a bit here and tweak up the part cooling and see what happens. I think the fan here is set at about 30% of the maximum, and yeah, it's doing fine. The other thing I really like about this printer is the ability to tune a print in real time. So by way of the knob on the front panel and the screen, you could tweak various parameters. So if you find things are getting a little bit squirrely, you can dial back the overall speed in percent. So if 100% is what the G code was programmed for, then you could dial it back to, say, 90% of the overall speed in real time. So as you dial back that number, you hear the printer gears and motors all shifting down and slowing down, or speeding up, as the case may be. That is super handy. I've used that feature many, many times now, in order to keep from print from totally becoming demolished. The other things you can adjust are extruder temperature, hot end temperature, bed temperature, part cooling fan. All these things are super handy to adjust in real time. You get real-time feedback. My ANET, ANET 8, you can't do that. And so basically it adds a lot of extra time in stopping a print, making the tweaks, reloading the G code, starting the print again. So having this feature is super handy. If I can pull up a video of the screen later, I'll do that as well. But the rest of the front panel is pretty standard stuff, especially if you've 3D printed before. Yeah, it works, and it works well. The other printers I've used are the MakerBot Replicator, the ANET A8, the Anycubic i3 Mega, the SnapMaker 3-in-1, and the A20M compares really well to any of these printers. The MakerBot being the worst printer and the worst company to deal with. Awful. Anyway, ironically, they were also the most expensive printer that I've ever tried. GEEETECH has been great on the sport end, and I got the new screen, so I'm going to be replacing that very, very soon. And that should get everything going 100%. And I'm going to do that chameleon print, the lizard print, so you guys can check that one out. But that's probably a 2 or 3 hour print, something like that, maybe more. Heat up time on this printer is not bad at all. It takes about 3 minutes to bring the bed up to 60 degrees Celsius and the hot end to 200 degrees Celsius. So that's about 0 to 3 minutes and you're ready to go. The frame is sturdy. It uses extruded aluminum frame, and you see that in a lot of printers these days. It's a pretty standard arrangement. It's very, very sturdy. No worries with it shaking while printing at all, or wobbly prints or anything like that so far. So I've printed a lot, actually, for the whole coronavirus thing. You know, printing face shields. Had that going quite a bit, and it's been very solid. No issues at all. Let's talk about print speeds. Normally, I have print speeds at about 60 millimeters per second. It might be fun at one point to take it up a notch or two and see how far and how hard I can push this printer before things get a little out of control. 60 millimeters per second is a pretty decent speed, and I don't see any issues at that speed whatsoever. My ANET cannot handle those kinds of speeds in general, that's for sure. So for a solid multicolor printer, I haven't seen that much out there on YouTube. And other places, you know, because it's actually a very affordable multicolor printer, especially with this build volume. We're talking 255 by 255 by 255, which is quite big for most home printers. I haven't come across any prints that I needed more than that, actually. And normally you'll find that on most 3D printers in the budget range these days. So this is a very healthy size. One of the things about this printer is that, well, I mean, what can you say? The fans on it are quite loud. And so I have it in a room where I do some other work as well. And it can be disturbing. It's pretty loud. Now, if it was off in another room, it would be fine. Wouldn't bother me at all. It is a bit bothersome being in the same room as me when trying to do other work. And it's not the part cooling fan, right? Or the fan that cools the heat break. It's not any fan on the upper part of the printer. The loud fans are the ones that are keeping the motor drivers and transformers cool underneath the frame. So, you know, I would rather be cautious on this, and that it's better to overcool those components and that's because they are prone to heating up and failing as a result of heat. For example, the ANET A8 had a known issue where heat would build up on the control board, causing it to fail. The board just simply couldn't handle all that current, and those motor drivers were heating up really badly. So I had to upgrade those and add some beefy MOSFETs. And here we have another view of the finished dog print, the stock dog print. And you can see the blended color in a little more detail here. Everything looks really, really good. No complaints at all. I'd have to say it's about as good as any other printer I've seen. And you can see the nice transition from orange to blue with that illusion of brown there in the middle. And I did end up printing off the chameleon or the lizard stock print as well. And you can see it's quite impressive, actually. You get a very clear distinction between the two colors. And that first bit of orange there at the underneath the head was just because I didn't purge the hot end quite enough to get the print started. But basically everything else looks really great. This came directly off the print bed, no cleaning up whatsoever. This is exactly the way it looked. So the settings are quite good. There's no excessive stringiness. There's a little bit of thing there on the tail, but not a big deal. Looks great. Looks really, really great. Now, in order to get that clear distinction between the two colors, you're going to need this, which is produced automatically in the print G code, and that's a purge block. And that cube is solid, 100% solid filament. And it's a necessary evil because you have to purge the hot end of old filament to make way for the new filament, right? To make sure there's no bleed in between the two. And there's really no way around that. Anyway, here is the finished calibration cube that was printing in the first half of the video there. And you can see all the numbers. They're all within, 0.1 of the spec, which should be a 20 millimeter cube. And you'll see there, it's very, very close on all dimensions. No complaints there whatsoever. If you'd like me to upload the steps per millimeter settings for that, I can do that. That's generally pretty easy to figure out, and I'm pretty sure straight from the factory, you're very, very close to that kind of accuracy. So there you go. That's the A20M by GEEETECH, and yeah, well, maybe that helps you make a decision one way or the other. All right. Talk to you later.